Hello, and thank you for joining today's webinar, Accelerating NSX-T Deployments with Apstra AOS. Throughout the presentation, please put in your questions in the chat window, and we will address them at the end. My name is Rami Ramaha, and joining me, Claire Delcourt. The agenda for today is: one, I will provide a solution overview and what is driving the integration. Claire will take it from there and give us a deeper dive into the solution, followed by a demo. Then we wrap it up and go over the questions that came in. Before I dive into the solution, on August 26th at VMworld in San Francisco, we announced the release of AOS 3.1. We have introduced key enhancements across the board in multi-domain unified group-based policy, increasing application availability and security. We've also done enhancements across intent-based analytics, accelerating troubleshooting, and root cause identification. Also, we've done enhancements and expanded our feature sets and multi-vendor support. A significant advancement that we introduced is the integration with NSX-T that closes the gap between the overlay and underlay physical network. And here, as quoted by VMware, NSX with Apstra AOS enables customers to treat the network infrastructure as code. This helps to accelerate deployment by bridging the gap with the physical underlay, reducing operational costs and simplifying troubleshooting. So what NSX customers need from the physical network? So they want to be able to bridge the integration and visibility gaps by bringing tighter correlation between the overlay and underlay to reduce human errors, where the underlay can be any physical network that is able to participate with the overlay NSX. Also, they want visibility into the reasons why workloads are impacted, like performance, availability issues. Another thing they want from the physical network is the ability to automate consistent policies within the domain and outside the domain of NSX environments. So they want to be able to easily maintain these consistent policies in a seamless and simple way in a hardware vendor agnostic underlay. Lastly, they want to quickly remediate any potential issues that surfaces in the network, which requires continuous monitoring and closed loop validation between the overlay and underlay as changes occur. So with the integration, we offer a single source of truth dashboard for all information, breaking down silos between IT teams, accelerating the delivery of business services. First, we streamline fabric network requirements for NSX-T infrastructure, validate end-to-end network configuration across physical and virtual, detect any misconfigurations in physical networks such as MTU, VLAN, and lag, and lastly, remediate anomalies across the whole fabric in a simplified workflow. We are the first and only vendor that can bridge the integration and visibility gaps in a pure software implementation across any physical hardware vendor, liberating NSX customers from being locked into a specific hardware. And now I pass it to Claire to give us a deeper dive into the solution. And again, as a reminder, please continue to put in your questions in the chat window.
Thank you, Rami. So let's have a look at the solution little bit deeper. So what do we mean by streamlining the fabric network requirements for NSX-T deployment? Streamlining the requirements for us as a fabric management solutions means first identifying the need for the NSX-T deployments in terms of fabric connectivity requirements. And there are three of them we have identified. First of all, for each physical server that is going to host the NSX-T deployment, I need to provide the proper fabric connectivity between my server and my top-of-rack switch. So I have to think about what is the server leaf link design I want. Do I want lag? Do I want an M lag? do I want to go with active standby or active-active links? And based on my design choice, it's going to basically require me to generate configuration of my top-of-rack switch as well as on my server to achieve the desired design. The second aspect of fabric connectivity requirements when it comes to deploying an NSX-T infrastructure is to be able to provide connectivity for all the different types of traffic that this infrastructure is going to generate and require. When you look at an NSX-T deployment infrastructure, there are different sets of nodes: the compute nodes, the management nodes, and the edge nodes. The compute nodes are going to generate 4 different types of traffic at the minimum: the management traffic, the vMotion traffic, the IP storage, and the overlay transport traffic, which is carrying my virtual machine traffic over in overlay tunnel from server to server. Each of this traffic is going to be segmented on the server side using a different VLAN ID. My management cluster and my management nodes are going to require connectivity to the same management network that is used by the compute nodes and the edge VM nodes. The edge VMs needs to be also connected to the management network. If it's a virtual edge node, it also will require server connectivity to the vMotion VLANs, the IP storage, as well as any extra connectivity that is required to connect my virtual workloads with external routers or bare metal servers for north-south traffic. So all those VLAN configurations means for the fabric to provide a certain type of L2 or L3 VPN connectivity across the different racks. And ideally, to keep the isolation between the different type of traffic from the server, but also in the fabric. The third requirement for the fabric is to make sure that the overlay transport traffic that is encapsulating in my VLAN ID 40 here is configured with an MTU that is higher than 6600 bytes due to the overhead of the encapsulation of the Geneve traffic. So I have all those fabric connectivity requirements that I need to fulfill before I deploy my NSX-T infrastructure. Those are not a lot of requirements, but they are highly error-prone as they involve configuration both on the top-of-rack switch and on the server side. And without a proper automation available to me as a network operator, it's a lot of work to do and basically a lot of error-prone workflow that are involved in the configuration of those things. And the higher skill I have, the higher mistake I could make in configuration of those things. So it's really important for us here to provide a better automation for the VLAN configuration, MTU configuration, and fabric configuration end-to-end. Physical and logical topology are decoupled, yes, but they are highly dependent. The configuration between the server and the top of racks has to match. The other problem of decoupling, or it's not a problem, but certainly an operational challenge is when providing network solution on the server and virtualizing on the server is that it increases the troubleshooting of the network, and it certainly reduces my visibility as a physical network administrator on what the network is about, because I don't really see what is in the server. So how do we solve this problem with Apstra AOS? First of all, and that's something that we have for a long time, is we accelerate the initial MD2 fabric configuration. We do that in a completely vendor-agnostic way. We work with multiple network operating systems running on the switches, and we basically help the physical network operator to streamline the design of their rack, the configuration, and provide closed-loop validation of the configuration. It means, for example, that from a virtual network automation perspective, I can now use AOS to streamline the deployment of VLAN of type L2 or L3 across my racks in a couple of clicks. AOS can do that using a set of technology like BGP VPN and make sure that all the routes that are involved in those virtual networks are correctly learned and distributed across all of my fabric leaves. Another advantage of using AOS for VMware NSX deployment is that it includes by default jumbo frame configuration for overlay networks, and it already supports that. So I have just using AOS in a couple of clicks, I can already design a fabric that is compatible already for my VMware NSX infrastructure and provide me with closed loop validation of the configuration from the network state perspective. The other advantage of using Apstra AOS, and in particular this new integration that we are launching with NSX-T, is that I have direct visibility as a network operator on where my virtual network and my virtual workload in NSX-T are. So with this integration, AOS is now capable of learning and collecting data from NSX-T manager directly and map this virtual information onto my physical topology and give better visibility to the physical network administrator on where the virtual networks and how the NSX-T nodes are connected to the fabric. In terms of how it's represented in the solution, we have a set of new NSX-T dedicated dashboard and remediation workflow that offer a way for the end user to see the NSX-T virtual infrastructure configuration, to understand validation, to highlight validation errors between the server and the top-of-rack switch, and to also have fast remediation workflow for any of those misconfigurations. For example, one of the misconfigurations that we are able to detect with this NSX-T integration is if the NSX-T node uplink configuration is not matching the top-of-rack switch node configuration that it's connected to, we can validate that end-to-end. So instead of having a validation that only includes the state of the network from a leaf and spine perspective, we are also able now to provide validations from a physical network perspective and virtual network perspective by looking at those NSX-T information. In the demonstration, I will show you how we we perform those validations, and an example of a manual workflow that involves user input error, and how we can detect those errors thanks to this integration and remediate it. For the demo, I will first switch to my screen. Now that my screen is loaded, I can open up the pre-recorded demo. During this pre-recorded demo, what we are going to do is to show you how, using AOS Web UI, I can deploy a brand new spine leaf architecture fabric to host my NSX-T infrastructure, and how I can create my using AOS, my fabric underlay virtual network to provide connectivity for all the transport nodes interfaces used for the overlay, NSX overlay traffic. So first of all, I will design and deploy my spine leaf architecture using AOS. Second of all, I will configure my underlay virtual network with VLAN ID 10 towards my rack 1 and rack 2 to provide L2 connectivity for my two transport nodes. I will show you how I can then easily deploy my transport nodes, and then what are the type of issues that could occur during those scenarios, even though I have automation, and how is the NSX-T integration in AOS able to detect better human errors and streamline remediation workflow. So let's go ahead. And first of all, I will show you how to design, build, and deploy the fabric in AOS. So the first thing I'm going to do here, I already pre-built my spine leaf topology, and I just had to specify to AOS how many spines and leaves are used for my fabric and how they are connected to each other, how many links I have between each leaf and spine, and how many racks I'm going to use, and how those racks are connected between the server and the leaf. Once I have done that in AOS, the only thing I have to do in terms of deploying that topology is allocating my resources, my ASN resources, my IP resources. And AOS will then figure out how to consume those pools of resources across the fabric, and we'll be able to then generate a configuration for all of those devices. I just have to tell AOS what type of device is actually my spine and my leaf, whether they are Cisco, Arista, Cumulus switches, and that's with those simple operations, AOS is capable of providing a configuration for each of the devices and pushing the configuration down to the V device. So here I'm in the stage phase. I've not deployed anything yet. I'm just in the process of deploying. I'm first of all staging. Once I've staged my design, I can review all my changes from a logical or physical perspective. From a physical perspective, I can see what are all the new leaf and spine and server that are going to be deployed by AOS. And I can also look at individual devices to look at what are the configuration generated. Build errors will tell me if I have any errors in my design that has been found by AOS. Once I have reviewed my changes, I can go into the active tab and commit them. The active tab shows me the active representation of my topology. In the dashboard, I can see the state of the deployment, whether it succeeded, pending or failed configuration, and I also have the state of the network from an intent perspective. The anomalies are the built-in validation that AOS performs from a IP fabric perspective, layer 2 fabric perspective, external routing perspective, to detect any violation of intent. A green dashboard means that I have no violation of intent, and I can and that my fabric has been properly configured. Once my fabric has been properly configured, it's time for me to create the fabric VLAN that are going to be used for my NSX-T overlay transport traffic. So doing that in AOS requires to create a new virtual network. This is not an overlay server-to-server network. This is an underlay leaf-to-leaf network. I can choose the type of network VLAN or VXLAN. Using VXLAN means that I'm actually leveraging BGP EVPN technology in the fabric to extend L2 or L3 virtual network across different racks. I just have to give the VLAN a name, tell in which security zone I want to deploy this VLAN in. It means that I only allow network communication within security zone 1 for that VLAN. And I have to select the server-facing ports that are involved in that virtual network, and whether they are of type untagged or VLAN tagged. In this case, an NSX-T requirement is to have server isolation of the overlay traffic in a different VLAN 100. So I want to tag my virtual network with VLAN 100 towards my servers. And here I see that I have to extend these virtual networks towards my two first racks, my leaf 1 and leaf 2, and with VLAN 100. So that's done. And if I wanted to create more virtual networks, that's all really I had to do as a process, a couple of clicks, and I can deploy really easily all my virtual networks across any hardware vendors. Once I have created the change, I can review it, again, logically or based on configuration, and commit it. Now my fabric is ready to deploy the VMware infrastructure. So I can go into the NSX-T Manager web UI and deploy my NSX-T nodes on my first and second rack. So I'm logging into the NSX-T Manager, and in NSX-T, the way you define the NSX-T node uplink network and configuration is by creating the node profile. So first of all, I'm creating a node profile that is going to tell NSX how many uplinks I want to use for this node, how are those uplinks logically configured, whether it's a lag or not, and what type of load balancing I want to do if I have more than one link. So here I'm using a lag, and I will use 2 physical uplink interface for that lag and do load balancing based on MAC address. As part of the uplink profile configuration, I'm also specifying the VLAN ID that I want to use for the transport traffic, which has to match the VLAN ID 100 that I originally designed together with for my physical network infrastructure as well. So here I'm using VLAN 100. I can also specify an MTU that needs to be at least 1600 bytes. Now that I have created my profile, I can use the same profile for all of my transport nodes. My transport nodes are those virtual switch and router agents that are deployed on the compute nodes and that are responsible for switching, routing, and encapsulating the VM traffic over the overlay network. I'm specifying the uplink profile I just created for this NSX node, and I just have to select a pool of IP I want to use for my virtual TEP interface, which is the IP interface that is going to be used for the overlay traffic. And I have 2 physical network interfaces. So as the first node is being deployed by NSX, I can go ahead and deploy a second node. I'm going to use the same uplink profile with VLAN 100 and wait for those NSX nodes to be properly configured. As you can see here, the NSX-T Manager tells me about the administrative status and the link status of my TEP interface. And right now, I can see that it has been properly configured, the admin status is up, and the link status is up. I also see that the TEP interface has been allocated an IP address 192.168.20.2. The SXT node number 2 is ready as well. I see that the IP address has been allocated and the TEP interface are up. From my perspective as a virtual infrastructure operator, I feel like my NSX-T node have been deployed correctly and I'm ready to deploy now VMs. So as I check again the connectivity status, and I verify that everything is good, I can go home and have a beer. I'm done with my work in deploying my NSX-T infrastructure. Before I do so, I do want to verify one last time that just with one more check, that I can ping from my NSX-T node 1 TEP interface to my NSX-T node 2 TEP interface. So when I do a ping and I ping towards my 192.168.22, which is one of my NSX-T nodes, I can see that actually I don't have reachability. I don't have IP connectivity. So that's a problem, because from an NSX-T manager perspective, I feel like I've configured everything according to the design that I agree with my physical infrastructure team. But still, I don't have connectivity. So if I look at the AOS dashboard again, from a physical infrastructure perspective, everything looks fine as well. I don't have any anomaly reported by AOS, and I've deployed my virtual network. So what went wrong? So in order to figure that out, I'm going to use the new features, the new AOS feature with the NSX, that is the NSX-T integration, and I'm going to go ahead and create a virtual infrastructure manager, which is, in this case, an NSX-T manager. And I'm going to enter there the IP address of my NSX-T manager. And I'm going to specify a read-only user that was created for me by the virtual infra team. Once I create that, AOS is going to connect to the NSX-T manager through the public API, and I can now tell AOS that this virtual infrastructure is running on the particular fabric I just deployed by adding the virtual infra manager into that stage environment and committing the changes. Once I have done that, AOS is going to automatically connect to NSX-T and pull information from it. AOS is also going to pre-configure a dashboard called Virtual Infrastructure Fabric Health Check. In this dashboard, I can see a different group of anomalies. I have VLAN missing anomaly, I have physical NIC lag status, I have MTU, low MTU anomalies, inconsistent MTU anomalies, and also a widget for critical services affected by VLAN misconfig. So I give AOS 1 minute or so to pull the information from NSX-T and perform the validations. And I immediately see here that AOS has detected two types of anomaly. The first one is hypervisor VLAN missing in the fabric. AOS is telling me that the hypervisors that are my NSX-T node 2 and connected to my rack 1 leaf 1 is missing VLAN 100 on the swap 3 and swap 4 fabric interface. So although I believe that I had configured correctly my fabric VLAN interfaces for all of my rack, with this validation, AOS is verifying that all the VLAN-backed interfaces that are configured in NSX-T also have a corresponding fabric VLAN to connect this VLAN from a fabric perspective. And he immediately detected that that's not the case. So the easy way to remediate this problem is by adding to my VLAN 100 the leaf 1 swap 3 and swap 4 ports. So instead of doing that manually and make a mistake again, I can ask AOS to remediate the anomaly automatically. AOS will then provide me with a virtual network change that is adding the missing port into the virtual network. I can review that change from a visualization perspective. I can see on the right side that I only had one single rack attached to my VLAN 100, while on the change that AOS is pushing is actually adding a second rack. That's great. That's exactly what I wanted to do, and I didn't have to do it manually, and I know that it's going to solve my problem. So I'm happy with my changes, and I commit them. Once I've committed the changes, with closed-loop validation, AOS automatically clear the anomalies from a hypervisor VLAN missing in the fabric, because I don't have any remaining fabric missing VLANs. And I can go ahead and fix my lag status, for example. In the lag status problem here, AOS is telling me that I have a lag configured on the NSX side for node 1 and node 2 on this particular interface. But the fabric side, I don't have any lag. It means that when I design my fabric for those racks, I actually did not design it properly, and I didn't do a lag on those ports. So in order to fix that, I would have to go back to my stage blueprints and fix my lag, fix my server attachment to the leaf to be a lag on this particular interface. So let's have a look at how those validations are performed under the hood by AOS. All of those validations that are displayed here are actually performed by intent-based analytics solution. It's 100% programmable. All the validations that we have with NSX-T have been pre-programmed and predefined by us, but IBA is a platform that allows you to predefine other probes, specific to your environment and extend them with even more validations that we would not have think about. So that's one thing. So this is the number of probes or validations that are involved in the NSX-T end-to-end server top-of-rack switch configuration validation. We also have things like hypervisor missing LLDP config. It's up to really to the user to be creative about what are the validations that are relevant to his environment. For each validation that I have configured, I can export the validation output into a custom dashboard so that I can have specific dashboards that are created for specific needs of my operational teams. For example, in here, I have a dedicated NSX-T dashboard, but I can have other dedicated dashboards for vSphere or specific for underlay fabric network states. There are all the probes that are developed using IBA are shared publicly on Apstra. We have probes for measuring layer 1, layer 2, layer 3 network states, data plane states, and other traffic patterns. Please feel free to go and check out all those validations and great probes on GitHub and so forth. We have the way that probes are imported from GitHub into the system is very easy. Probes can be exported from AOS into another AOS machine as well, and imported back into the system by simply copying the text, going to the destination system, and importing the text as a probe again, and creating the probe. So it's a really simple mechanism for collaborating on network validation and a great tool for engineering or DevOps type of engineers to perform advanced validation in the network. So here I'm creating, for example, a probe to collect more information from my NSX-T information that AOS didn't have by default. I can rearrange the view as I want, and collect more information about, for example, MTU or NSX nodes information, and create that view and place that view into any of my existing or new dashboards. So this sums up the integration with NSX-T that we have built in AOS, and thank you all very much.
Thank you, Claire. Let's go back to the presentation, and so in summary, what we saw in the demo is that we have a tight, seamless integration between AOS and NSX-T, automating network policies to meet NSX-T physical infrastructure requirements. We've seen this implementation actually is hardware agnostic, enabling consistency in terms of having service intent across the entire infrastructure. Also, the continuous closed loop validation, smooth, non-disruptive operations, and lastly, the visibility that provides network topology mapping between the overlay and underlay that helps in accelerating troubleshooting in situations where, for example, you may have some performance issues. We have a few links here that to help in adding more color on what we talked about today, from the data sheet, a solution brief, a reference design where we have between AOS and the NSX-T. Also, there's a link that we've for Tech Field Day that adds some more demos that beyond what Claire covered today. who wants to learn more to go into these resources and take a look. So this wraps it up for us today. We will take a look at the questions that came in. Again, if you have any questions that you want to ask, please put it in the chat window. And we got a few questions that we will go over right now. But again, just keep the questions coming in. So I think the integration that we talked about, that we demoed, the question is the integration available today? So maybe Claire, you can cover that.
Right. So this integration will be available in the release 3.1, which will be generally available on September 16.
Okay, excellent. So the other maybe follow-on question to that is to you, Claire. How can someone deploy AOS?
Right. So AOS is a single that can be deployed as a virtual machine. It's fundamentally an AOS server virtual machine, and it can run on any hypervisor in your data center, ESXi or KVM. And we basically, through that single instance, manage your network devices. The network device management is done through a management network interface, typically that is connecting to the management interface of the devices.
Okay, excellent. So there's a question here about if I'm on an existing Apstra customer, can I upgrade for free? And the answer is yes. If you are a customer who already licensing the Apstra code, then you can download the latest code for free. Another question for you, Claire, I think that may be worth covering is, so we talked about the NSX-T integration, and then the question is, what about NSX-V? Do we support that type of integration?
We support NSX-V deployment through the integration we have with vSphere. So instead of directly talking to the NSX-V API, we actually directly connect to talk to the VMware vCenter server API and collect the same type of information we do with the NSX integration, collect this telemetry, and provide validations using intent-based analytics.
All right, excellent. So another one that just I think that came in is, how is our solution different from the others? So maybe I'll jump on that one. So as I mentioned, our solution is a complete solution that includes everything from the analytics, root cause identification, and the whole integration versus what you may see a fragmented solutions in the market. So that's number one. Number two, we have a pure software implementation that runs over any vendor, hardware vendor. So we're not tied into any specific hardware vendor or network operating system. So that's the key things that we have. And also, what Claire showed in the demo is that we offer a single source of truth for all things related to design, building, deploying, and operating a data center. So let me add another question that came in. Maybe that's for you, Claire. Do you use what telemetry is used to detect anomalies?
Right. So we use different telemetries from either the network devices or other systems to perform anomalies. So based on the anomaly, the telemetry data that you need to collect is going to be different, and we make sure that we collect the proper data for specific validations and nothing else, nothing more. The way we collect this information really depends on the end system and the API available from this end system to do so.
Okay, thanks. So maybe another thing is to talk about the network device operating systems that we support. So what is it? What devices do we support? How can we add new devices to the AOS ecosystem? And exactly, do we need the vendor switch APIs to support that?
So we have a list of predefined device hardware profile that are in AOS that we support. So from a hardware perspective, there's, I would say, a list of like 30 of them, and we provide support for those. In terms of device operating system, we support all the industry-leading ones. So that includes NXOS, EOS, GNOS, and also open source one like Sonic and Cumulus.
Okay, thanks. So maybe a continuation on that one. What if I have an existing Cisco Nexus 9K equipment? Do we support that?
Yeah, we do support Nexus 9K in standalone mode in that case.
Okay, so it's not an ACI mode then?
Correct.
Okay. So the other thing is maybe a continuation on the device operating system support. What is Apstra's contribution to Sonic as a network operating system?
Right. So we are one of the leading supporters and contributors to the open source project that is Sonic. We can take one more digit.
Okay, excellent. So there's another question about the scaling of AOS in data centers and how high can we scale? So today we work directly with Fortune 50, 500, and 2000, and we're able to deploy high-scale class architecture, 3-stage and 5-stage topologies that can actually support thousands and thousands of network switches in the data center. So from a scaling perspective, I think we're able to do high scale based on that. Another question that may be worth, another one that came in is about if I'm a VMware partner, how can I engage with Apstra? So we definitely, the VMware partners, selling NSX, and they can definitely take a great advantage of, selling AOS, Apstra AOS, because they can increase bring in a larger value to their customers. So the way they can engage Apstra is really by, go to the website, apstra.com, and click on Contact Us, and we'll be in touch with you on that. There's another question, the last one, and I think, again, if there are more questions, we will keep answering them. The last one is about Cisco ACI, and do you use ACI or Fabric Path or OT? Maybe Claire, you can address that one.
Right. So, like I said, we don't use ACI. We provide the same business services and standard type of protocols, but we don't use ACI or any other proprietary features because the goal is for us to minimize vendor lock-in. So we really try to use a set of technology that are common across vendors. Okay,
great. So another question is about the support and what support do we provide that Apstra provides. So we have a white glove support model and 24/7 follow the sun support for any network built and managed by AOS. And another question, I think maybe that's for you, Claire, is can AOS troubleshoot the underlay network device via TLS SSH sessions?
That's a great question. So I think the question is really about do we have an SSH client within the AOS web UI? Probably. The answer is no, but it's something that is definitely on our radar.
Okay, thanks. One last question that that we can answer right now, and if there's more, we will definitely answer them. But the last one that we have is, do I need NSX if I use AOS, Apstra AOS? Maybe Claire, you can speak to that.
Right. So, when it comes down to providing, basic server connectivity and macro segmentation in your fabric, AOS is covering all those use cases. But, if they're for all the VMware tools all the tools that provide the VMware and solutions are, bringing a level of complexity that we're definitely not covering. For example, stateful firewalls, deep inspection, and VPN technology and so forth should be done clearly on the server side as much as possible to decouple yourself from the fabric. And in that regard, we do believe that NSX is the best solution.
Okay, thank you, Claire. That ends the questions that came in. Feel free to contact us. You can reach out to us through Twitter, LinkedIn, Facebook, or even through the website. Contact us if you have any further questions, and we'll definitely get back to you on that. With that, appreciate attending the webinar, and have a great day.